is a silicon wafer. The silicon wafer. There are two sides. One side polished and the other side is non-polished. So first, when you take the silicon wafer, there is a crystal structure inside. We know theoretically. Silicon having a valence band, conduction band, these things. So that student should be very careful. You should know. So this card will tell you what is the options of taking it, which crystal domain it belongs to. Then this dust, this contains huge dust, and we have some hand experience. So you have to clean it. So you need a very strong knowledge about using acetone, hydrogen sulfide, and H2SO4, and all those things. So that is basically steps of cleaning. Then these are the furnace. In that furnace, we use oxidation diffusions. So I have mentioned P type, N type. So you can use boards where you put the silicon and then you create a cake of boron and then heat it. The boron will deposit on that and then it will create a P type. So that process is actually carried out in this way. So P type, N type material, and then we make them cured. And some of the clean rooms are there where we use the chemicals and chemical handling things. And after that, when you have the P type, N type, now you need to produce a pattern of anything. So how to create a pattern on this? First, create a AutoCAD pattern which we call as a mask. So whatever the thing we know in our old days, developing of an image in our dark room, the same process also happening here. Here you create a mask, then on this you paint a material, we call them photoresin. Then we put the mask on it and then we expose it on UV. Either the portion which is under the mask will be solidified or the rest of the portion will be solidified. But after that you create an etching. So you etched out the material and the pattern will be deposited on that. So that pattern may be a PN junction pattern or maybe a PNP junction of transistor. Then you need metallization. You have created a PN junction. Then you need two probes to be coming out because finally you need a voltage and current. So you need metallization using some kind of vapor deposition. So that I will show in the next one. You can see one interesting thing. This is a wafer on which how many number of chips actually made. And in each of the chips you can cut them using laser cutter, and if I place it in the light, you can see each of them having a small pattern inside, which is basically nothing but a pattern of a switch. It is actually a switch. The switch also, so that you can see. This one? Yes. So I can go there. Then I think better.
I think so.
Yes, you can see.
So that everybody can see.
Yes.
So please show the silicon sheet first.
Yes, I will show you again. So this is actually a chip. Inside that you will see small things which is actually a chip, and inside the chip there is some pattern which is a switch. You can cut them and you can make the bonding, then it will act as a switch. Okay. Now this is actually created using MEMS technology, micro electromechanical system, means a system where mechanical up down of a beam made on that. So these are actually a beam which is actually hanging. You cannot see it in a naked eye. If you create a voltage on it, it will make like this kind of things, and that will change the capacitor, and that way it acts as a switch. So you can now see more closely the pattern inside it. If it is actually reflecting, then you can see. And this is actually a silicon wafer. One side is polished and other side is non-polished.
So you're using only silicon or germanium also?
We actually use silicon because silicon has the better property of conduction. But currently, if you go for automobile or high power industry, silicon have a problem of high power handling. So now it's changing to its dimension to 3-5 semiconductor like gallium nitride, gallium arsenide, silicon carbide. So in Kolkata, the office open Global Foundries. They are actually doing on gallium arsenide, gallium nitride based things. Then silicons are very old.
So simply for silicon, for doping purpose, you're using arsenic or antimony?
No. On silicon, either you have to put P-type or N-type. For P-type, you have to use boron, and for N-type, you have to use phosphorus. So that's the two material we are using. And not only that, after this chip you made, that chip contains sensor and circuit. Then only it is the actual chip. Only a sensor, it is just a primary front end. But the final chip is the full one. So we used to create students the knowledge, they learn how to make it. We are using training program in summer and winter for undergraduate colleges and engineering colleges, where students are coming to train themselves using a silicon, how to handle a silicon to create a junction, and how to make a circuit in analog and digital one. So that training program we usually organize. The only thing I want to highlight here more, now these designs are changing more inwards AI based. Why? If you do designing from the scratch, it will take time. And in a semiconductor industry, time to market is a very important. You cannot spend max time, your competitors are ready. So now AI will help you to create a system that it will give you methodology that you can start in that way, it will help some time. It is the strongest material nowadays. So creating graphene on any kind of glass or silicon, you need chemical vapor deposition. So that is the process by which we put graphene deposition. Using graphene, you can create insulator, you can create silicon. And not only that, stealth technology, where you can paint graphene with a pattern on a material so that the light reflects on it and it will not come back to me, so that there is no deflection. So that called intelligent reflecting surface. Using the voltage on this material, you can change the direction of the beam. So we call this technology used in 6G communication. So that is basically in that room. And also I want to highlight that machine. That one is a plasma chemical vapor deposition chamber. So plasma generating and using plasma, you deposit some kind of material. So creating plasma is an important thing. And remember, for that, a student should also have the knowledge of how a plasma should generate it, what is the electrons whole pair, how the electrons are rotating, clouds are formating, and also a bit knowledge about quantum. Now, quantum semiconductor, quantum theory, basics of quantum theory. Even if what we studied PN junction, we have to give students a knowledge of a EK diagram, that is called energy band diagram. So if that energy band diagram is actually what we studied in books, it's a partial thing. In actual, it is a quantum domain explanation. So that should be very clear for the students. So this is actually a plasma chamber. And several other things are also doing in that room, like sputtering, thermal coating. So all those are
1906 to 1955. That is the history by Jadavpur University.